Welcome back. Lever voting machines, despite their promised advantages, turned out to have a lot of problems too. They were very complicated, they were huge, took up a lot of room to store, and above all, they were just very, very expensive. Each machine might cost thousands of dollars. So in the 1950s and 60s, at the dawn of the computer age, inventors once again started looking to the latest modern technology to find a new and better solution to the voting problem. What they came up with was based on this kind of technology, computer punched cards, like this IBM card from the late 50s. Punched cards were a form of information storage that usually would have data entered into them with the aid of a punch device that was something like a typewriter. But in the late 50s, some inventors came along and found a way to make a portable punch card data entry device, like you see here, in which a person could just enter information into the card by punching out little holes in a card that was pre-scored, that is, that already had each potential place for a hole partially cut out. And you could just punch out the holes you wanted to open with a stylus like the one seen here. In the late 50s, some people got the idea of applying this technology to voting. And the result was this machine you see here, the Votomatic. Originally developed in partnership with IBM and later spun off, the Votomatic was potentially a good market for IBM. Voters would vote using this device to record their votes onto punch cards, and the punch cards could then be brought back to a counting facility where a very expensive IBM computer device would read in the cards and tabulate up the choices. So what we see here is in some ways a return to a paper-based ballot. It's literally a piece of paper in which the voter encodes their votes. On the other hand, it's very difficult to just look at that card on its own and vote your choices. So we came up with these designs of machines that would make it easier for voters to do that data entry. So the way a machine like this would work was the voter would take a blank ballot card, like the yellow one you see here, and insert it into the machine from the top. Then they would use a ballot booklet, as you see in the machine, and a stylus like that to punch out the individual holes. So we can zoom in here a little bit, and you can see a bit about how this design works. The ballot consists of multiple pages, and you turn to a different page to expose a different column on the punch card. In this way, the whole space of the punch card can be used. It makes for a very compact representation of your choices, and yet it's still at least partially human readable because with the aid of the device, you're able to make your selections using only a mechanical stylus. The ballot you see here comes from Palm Beach County, Florida, during the 2000 presidential election, which was a very important time for punch card voting technology. That might give you a clue as you try to think about what could go wrong with punch card voting machines. Hi, welcome back. So it turns out there's plenty that could go wrong with punch card voting, as anyone who remembers the 2000 Florida presidential election knows. What happens with punch card voting is very similar to lever machines in that there's no good way for the voter to verify immediately with their senses that their vote has been recorded correctly. And coupled with poor ballot design, this leads to many, many possibilities for error. The 2000 presidential election was decided by a margin of just 537 votes in the state of Florida out of 6 million ballots cast. There were numerous accusations of fraud and inconsistency on both sides. But one place where some problems are very well documented is with these Palm Beach County punch card ballots, which are known as butterfly ballots. The butterfly ballot user interface was just really, really bad. So imagine trying to vote on this, even just looking closely. You can see a little bit of a problem. If your attention is focused just on the Republican and Democrat choices, you'll notice that there's a hole in the middle between them that if you're only reading the left side of the page is fairly ambiguous. Is that the hole you're supposed to vote for choice 3, for choice 5? Especially if you're holding the ballot at an angle, which is how most people actually interacted with it, the alignment here can look off, and it's just very easy to mistakenly make the wrong choice. And in fact, people did. In Palm Beach County in this election, almost twice as many people voted for Pat Buchanan, choice 4, as in similar neighboring jurisdictions with similar demographics. Even more surprisingly, thousands of voters incorrectly marked 2 choices for president, choice 4 Pat Buchanan, and either the Republican or Democrat candidate. What does this imply? It's almost certainly many of these voters started marking choice 4, realized they made a mistake, and then marked one of the other choices. Because these votes were counted as having been marked for 2 candidates, the choices were discarded completely. Those selections were invalidated. But it's a striking example of how usability problems in this kind of ballot design can lead to massive voter error. Another problem with punch card voting is this stuff. This is CHAD. CHAD is the result of punching out all of those little holes in the punched card. CHAD accumulated inside the machines, and if they weren't properly cleaned and reset between elections, might make it difficult to completely punch out the holes for a given candidate during the election day. But that wasn't the only problem with CHAD. The other problem was this, that each hole in the ballot, although it's supposed to represent a binary choice, punched or not punched, can actually be in a lot of intermediate states. You can see several of those here. We have pieces of CHAD that are detached on only 3 sides. We have pieces of CHAD like the one on the right that is detached on 2 sides and dimpled. Terms like hanging CHAD, pregnant CHAD, dimpled CHAD, all of these to describe various intermediate states between punched and not punched, entered our national vocabulary in the wake of the Florida 2000 election because of the very difficult hand recount process that followed and very contentiously tried to classify each of these ballots into one state or another. Now, we could come up with various rules for how to classify each of these intermediate states. If the CHAD is detached on 3 sides, does that count as a vote? Well, we can make a rule in advance that says that. But even if we do, there's another problem, which is that the actual state of the ballot is very fragile and can be influenced and altered just naturally in the process of counting. Running these ballots through a machine, you'd probably find on the floor afterwards many pieces of CHAD that had detached during the counting process. So even if you counted them again, they wouldn't be in the same state. This kind of fragility and inconsistency makes doing an accurate recount next to impossible. Another problem with CHAD like this is if the piece is not fully dislodged, it might be altered one way or another deliberately and maliciously during the counting process. So someone could knock off a piece that hadn't been fully detached, or they could just smooth it with their fingernail, pushing it back into place. And in analyses that researchers have done since, they've seen that it's almost impossible to tell whether that's been fully dislodged and partially dislodged and put back, or is unvoted unless you examine the ballot under a microscope. And even in Florida in 2000, we didn't go to such great lengths to, as a microscope to determine how people voted. So the arguments over the Florida presidential election were ultimately decided in the Supreme Court, but it still represented a landmark moment in the history of voting in the U.S. The problems and the national embarrassment that these Chad problems caused basically ended the widespread use of punch card voting. And instead, Congress allocated money to the states to upgrade their voting technology and introduce a range of new systems, things that look like these: touchscreen voting machines and optical scan voting machines that read pencil marks on paper ballots. These styles of voting machines are going to be the focus of our next lecture, because both of them are systems that introduce computers and computer software into the polling place. Today, there's a tremendous amount of variation in the kinds of voting technology used across the US and in countries around the world. If you look at this map, which is several years old now, you can see that in the 21st century, optical scan and touchscreen computer voting machines are the predominant technologies, but especially in population centers. But there's still paper ballots, lever machines, and even punch cards in use in some parts of the country. This week, for your engagement assignment, what I'd like you to do is find out specifically what kind of voting technology is in use where you vote. Find out the specific manufacturer of the technology, which of these classes it belongs to, maybe how long it's been in use, and what came before and why the switch was made. We'll provide some links on the website to help you research these questions, but another thing you could try to do is just contact your local election officials and ask. That would be a great way to begin the conversation. I hope you'll report back in the class forums about what you find out.